What's up, ninjas? Congratulations on completing the previous video of day 3 on dApps. Now it is time to put your new knowledge to the test with a few multiple choice questions. Feel free to rewatch the previous video to bolster your understanding of this topic based on how you go in this quiz. Ready? Let's begin. First question. How does a dApp interact with a browser extension EVM wallet? And the options are: the browser extension injects a Web3 provider into the window global, and the browser provides native Web3 APIs. I'll pause for a bit while you think of the answer. And the answer is, the browser extension injects a Web3 provider into the window global. Did you get that right? So this is precisely what happens. Your EVM wallet, such as MetaMask, will take the window object that is exposed within your browser. That's a global object, and it sets window.ethereum on it. And that object provides an API which EVM dApps know how to interact with, governed by EIPs. So they're standardized across multiple browser extensions. What a browser doesn't do is expose native Web3 APIs or EVM APIs, etc. None of that is from the browser intrinsically. That's what browser extension wallets do. They bridge that gap, and the way they do that is what I just mentioned. All right. So here's a resource to check out. One of the most popular EVM wallets is MetaMask, and they have a reference page for the provider API, or the Web3 provider API. Note that this is the simpler version of how things are done. In fact, there is a more advanced version which involves the case when the user has multiple browser walls involved. So yeah, that's linked inside this document as well. So go check that out as well if you want to learn about this more. Next question. In order for a dApp to interact with a smart contract, it needs blank. The options are: the smart contract's deployed address, the smart contract's EVM bytecode, and the smart contract's ABI. I'll pause for a bit while you think of the answer. And the answer is the deployed address and the ABI of the smart contract. It needs both of those, right? What it doesn't need is the EVM bytecode. So the EVM bytecode is the compiled code that is interpreted by the Ethereum virtual machine, run by the VM, essentially. Now, that's not human readable and doesn't really give you any clues as to what its interface is. So if you want to interact with it from your dApp, you would need to know how to call it, right? And that is precisely what the ABI gives you. The EVM bytecode doesn't give you that unless you attempt to reverse engineer it or something. But that's another topic altogether, right? So the deployed address basically says where I'm going to talk to, and the ABI tells you what messages you can send, what are the function names, what are the parameters, etc., right? So with those two things, you know how to talk to a smart contract within your dApp. Now, a good way to learn about this is to read the VM documentations for its read contract function. VM being a very popular library for dApp client code. The read contract function tells you, okay, here is the address that you're interacting with, here's the ABI, and then I can go interact with it. So yeah, go check that out. Next question. When you query a smart contract, do you need to submit a blockchain transaction? Basically, yes or no. I'll pause for a bit while you think of the answer. And the answer is no. And the reason for that is because a query is a read operation as opposed to a write operation where you change the state of the smart contract. So a transaction on the blockchain is essentially saying, here's my start state, here's my end state, and my transaction is going to bring you from this to the other one, right? It's a state change. A transaction on a blockchain is a state change of the blockchain. So a write operation requires a transaction, whereas a read operation does not. All right, and here are a couple of documentation pages from the Solidity docs that I'd like you to check out, or sections I should say. on the contracts page, check out the pure functions and the view functions. So these functions are marked as pure view. They are read-only functions, and therefore you do not need to actually use a transaction on them, right? Functions that are not marked pure or view, you will need to use a transaction because those are write operations. Now you have tested your knowledge with a quick quiz, and I wanted to know if you got the questions right or if there's anything that you were not sure of. If you need to clarify anything or have any questions, add them in the comment section below. All the links for the resources mentioned earlier will be provided in the description below as well. Thank you for watching, and see you in the next video. But before you go, note that this is a preview edition of the video that is part of the 7 Days of Injective course, and we are creating the full version of the course with all the bells and whistles. So if you watched this far, I'm sure that you'll be keen on that too. Do sign up using form by scanning the QR code or clicking in the link in the description of this video. For now, on to the next video.